Welcome to the Unit 1B and 1C test review, which is talking about increasing, decreasing intervals, domain, range, zeros, y-intercepts, and end behavior of the function. So we're looking at graphs in this case. So let's start off with number one. So number one is an exponential function. I'm going to first point out in exponential functions, there's an asymptote that runs right below the bottom of the bottom tail of the function of the graph. So we have the asymptote right down below. And so that's going to come into play when we're talking about some of these characteristics. So the first thing I will start with usually is domain and range. So domain, we're talking about all the x values of the graph. So what I do is these are continuous graphs, meaning you can take your pen or pencil and just draw the whole graph out without lifting it up. There's no breaks in the graph. So we're talking, how far left will the graph go? Well, this graph is going to keep on going left forever. Domain, thinking x values are left and right if you're thinking the coordinate plane. So it's going to keep going left forever to negative infinity. So the domain starts at negative infinity. And then as we follow it down, follow the graph, how far right will it go? Well, there's this asymptote. The asymptote's not preventing it from going to the right. It's preventing it from going down further. So this will continue right forever to positive infinity. Range. Now let's talk about this range. Range, I think it's the y values, but I also think how low will the graph go? What's the lowest point or coordinate on the graph to what's the highest? So the reason why I go lowest to highest is look at the y-intercept. If you look at the y-axis, the lowest, so I start with the lowest because these are the lowest numbers. -8, -7, -6, this is negative infinity. So we start at the bottom, the lowest, and go highest. Well, if we're looking at our graph here, following along, the lowest coordinates are right along on the right side here. Where will this graph go to, or what's the lowest coordinate it could possibly go to? And when you're looking at this, that's going to go down, but it goes down and there's an asymptote that prevents it from going any further. So we just look at, where's this asymptote? It's at -3. So it's going to go down to -3. So the range starts at -3. And I'm going to put a parenthesis because we can never actually get to -3. There's no coordinate at -3 on the y value. It's an asymptote. So we're just going to say it's -3. It's not included. That's the parenthesis. And then we're going to go up, follow the graph up, and it's going to keep going up to positive infinity. All right, so that's talking domain range. Now let's look at increasing, decreasing. Increasing, decreasing is looking at the graph, start on the left part of the graph, and remember that's what I have in my head, that I'm walking down from left to right. So I'm walking down this absolute value function or exponential function, and it's decreasing the whole way. So now I have it labeled. Now we can look at how far left will this start decreasing from, and it's going to start from negative infinity. And where will it stop decreasing on the x values? Well, it's not. So it's going to continue to the right forever to positive infinity. Is there any increasing portion of this graph? No. So we write none. Don't leave it blank, please. Zeros. Let's erase. This is where the zero would be. So 0 is where it's across the x-axis, or intercept the x-axis. We'll just put -1.5. Estimate it to your best of your ability. Y-intercept looks like at -2. End behavior. Now we're talking about the ends of the graph. So the left end of the graph and the right end of the graph. So start with the left. Which two directions is it going? Well, this arrow is going left and up. How far left will it go? Well, it'll continue left forever. So, oh man, it'll continue left forever to negative infinity. How high will it go? How far up? Well, it'll continue to infinity. So as x goes to negative infinity, that's the left, the y is going to go up to positive infinity. Now looking at the right side of the graph, which two directions is it going? It's going right. And if you follow it from the left to the right, it's going down. Now, how far right will it go? Well, it's going to go to positive infinity. How low will it go? Remember, there's an asymptote that prevents this graph from going any lower than the asymptote. So we're going to say it's going to go down to -3. So it'll approach -3. So we're going to go say it goes to the, x is going to go to the right to net positive infinity, and x is going to go to or approach -3. And there it is. All right, next one, number 2, absolute value. So we got domain, how far left will the graph go? Negative infinity. How far right will it go? To positive infinity. So domain, negative infinity to positive infinity. The range, what's the lowest y value? Right down here, there's an actual point. Remember, a graph is an infinite amount of closed points put together, and that makes up the graph, the line. So we have a closed point here at -4. That's the y value. A closed point means we need to include it. The bracket means including -4. And how high will they keep going? Both sides of the v will continue up forever and ever to positive infinity. Zeros. Looks like we have 2 zeros at -6 and 2. Y-intercept. Looks like we have 1 at -2. Increase and decrease, we haven't talked about that. So I'm going to label the graph first. Start on the left, and left to right, it's going down, so that's decreasing. And then as it hits this vertex, minimum point, it's going to go back to increasing. So now we need to label the segments that are increasing and decreasing. Increasing and decreasing intervals, segments, intervals. So how far left will this segment? Where does it start? It starts at negative infinity. And where does it stop decreasing? At -2. It's always the x values. So x, x. So it is decreasing from negative infinity to -2. Where does it start increasing? Well, it also starts increasing at -2. And how far right will that go? It'll continue forever to positive infinity. All right, talking end behavior. End behavior, we have 2 ends of the graph, left end, right end. Left end, which 2 directions? It's going left and up. How far left will it go? Negative infinity. How high will it go? How far up? Positive infinity. So our left is always our x value, left and right, like the x-axis. So the top line here I'm going to say is x goes to negative infinity. The y value is going to go up to positive infinity. On the right side, the graph is going to go to the right, and it's going to go up. On the right, how far right will it go? It'll continue forever to the right. And how high will it go? It's going to continue up forever. So our second line here, as x goes to, remember your right and left is your x, up and down is your y. As x goes to infinity, the y is going to go to also infinity. All right, let's get to these rationals. So domain, this is where domain can be. There's going to be 2 parts to our domain. We have 2 parts of the graph. You cannot draw the graph. Like if I drew the graph, I have to lift my pen to draw the second part. So that means there's a break in the graph. What's causing that break is this asymptote. So when we're talking domain, you start on the left always. Left, how far left will that go, that arrow? Well, it'll continue left forever. There's no asymptote there, so it starts at negative infinity. And that portion of the graph, as we follow it, what's the farthest right that portion of the graph can go? And there's an asymptote right there at 2. So that is as far right as that portion of the graph can go, that segment. Now there's another segment of the graph. It starts over here on the right side. And it starts right on the other side of the asymptote. So we're going to say it starts. Remember the parentheses means it's not included. So we're not including 2, but every number to the right of 2 on a number line. And how far right will this graph go? There's no asymptote that's preventing it from going right forever, so to infinity. And we'll put a union in, just a U in the middle, just to say that these are both segments of the domain. Now range, we gotta go to the lowest y value, so down here to negative infinity. Where's that portion of the segment top out at? Well, there's another asymptote running right, that's horizontal. that runs at 4. So that's going to, this bottom portion of the graph tops out right below the asymptote at 4. And then the other portion of the graph starts at, on the other side of 4, the asymptote, and it'll continue up forever to positive infinity. So this is pretty much just saying from negative infinity to infinity, not including 4. Every other y value is included in this graph. Zeros, let me erase this stuff so then I can actually see what the original graph looks like. Looks like there's only 1 0, and we'll say it's at 1.6. An estimate, if you have a number close to that, you're good. And this one looks like it's at about 3.5 for a y-intercept. Increasing, decreasing. So I'm going to look at each portion of the graph from left to right. So the first portion of the graph is going down, so that's decreasing. And the second portion from left to right looks like it's also decreasing. All right. So from left to right, they're both decreasing, so there's none for increasing. Decreasing, how far left will it go? It'll continue left forever, the first portion. Decreasing from negative infinity. Where will that stop decreasing? X value, well, it's not going to stop decreasing, but at 2. At 2, it cannot go further right than 2, so it's really going to look just like the domain. And the second portion starts decreasing at 2, or just to the right of 2, not actually at 2, not including 2, and it goes to the right forever to infinity. So decreasing portion is exactly the same. End behavior, when it comes to rationals, we're only going to talk about the farthest left and the farthest right. There's other ends to the graph. These other ends, we're not going to talk about the middle ones. There's end behavior with those, but we're going to talk about the farthest left and the farthest right. So the furthest most left arrow, what's happening, which 2 directions is going? It's going left, and it is going to go up. So if you follow it from further away, from the end, it's going left and up. And how far left will it go? Negative infinity. How high will it go? How far up? Well, it's going to top out at right below 4. So it's going to go as x goes to negative infinity. So that's the bottom one here. This is x value going to negative infinity. The y values are going to go up to 4. On the right side, which 2 directions is going, you can follow it from a little bit before the end of the graph. It's going right and it's going down. So it's going to the right forever. And how low is it going to go? How far down? It's going to go top, or it's going to bottom out at that asymptote again at 4. So right to positive infinity is x values is right, going to positive infinity. Here's the top one. And down, the y value is going to go to 4. And there we go. And there's nothing that goes in the end behavior lines. I don't know why those were there. All right, moving on. Which of the following function have a range of 4 to infinity? So for these, we got to do a quick graph of each one. So a quick graph of each one. We haven't studied linear functions, but plus 4 means that's a y-intercept of 4, so I'm going to put a y-intercept up a little high. I'm just going to do a crude graph, just very rough sketch of each graph. So that's the top one. We have the square root function up 4, so it's going to be like here and up. And that's at the y value of 4. This means left 4, so that graph is going to be on the left. It's going to be a quadratic. Looks something like this. Very crude graph, but it'll help us figure out the range on each one. This means up 4. So that graph is going to be a quadratic that's going to be up at 4. So this is at negative 4. Absolute value, this means up 4. So that graph is going to be, and you can graph each one of these on Desmos. I just don't want to do that and waste all of your time. And this last one, we haven't studied log functions, but a log function, this would be up 4. So it'd be, log function goes through 1, 0. Again, we haven't studied them, so it would look something like this. If I haven't studied it, it's not going to be an answer. Looking at range of 4 to infinity. 4 means the lowest y value on the graph. So the lowest point of the graph, lowest point of the graph is going to be at the y value of 4. Well, on our first one, 4 is right here. This portion of the graph is lower, so that can't be right. On this one, the lowest point of the graph is at 4, and then it continues up to the ever to infinity. So that's one of them. That's the range. This one, the lowest y value is at 0. So that's not right. Lowest y value here, the lowest point is at 4. 0, 4. So, and then both the right and left of that graph go up forever to infinity. So that's the range. Next one over here has the lowest y value at 4, and the graph continues up forever. Awesome. That one works. And here's at 4, but there's a portion of the graph that's below that. And we want just the portion above. Well, so that means that doesn't work. So there's the 3. All right, next one. Or what interval or intervals is f decreasing? So we got to look at our graph here. And first I would go start on the left side. Think about myself walking on this graph and going, first it's increasing. At this maximum point here, it's going to turn, the graph is going to go down and decrease. What are we looking for? Decreasing. So we're looking from this point here down. And there can be multiple intervals. There's the big one from -2, x value, to infinity, to the right forever. So that's x values. So we're looking for -2 to infinity. Don't be fooled by the negative. That's not right. -2 to infinity right below it. Cool. We have to look at each one though. -infinity to infinity. Well, that's -infinity to infinity, but this is increasing, so no. -infinity to -4. That's right here. That portion of the graph, nope, that's increasing. -infinity to -2. That's an increasing portion, so no. -3 is here. -3, the x value, to 0 is here. Well, there's a portion that's increasing and decreasing, so we just want decreasing, so nope. -4, which is here, to 0. Nope, there's a portion that's increasing and decreasing, so nope. And -4 to -infinity, that'd be going opposite way. That's not right. We always label them left to right. So there's only one here. There can be more. Like for instance, I could say 0 to infinity, or like written like this. That would be one, because it starts at 0 here, and to the right to infinity would decrease. So there could be a portion of the interval, of the overall interval, that would also decrease. All right, over what intervals is f increasing? So from left to right, label it first. Well, that's increasing. And left to right, that's also increasing. So every part of our graph here is increasing. And so we have, from left to right, this portion is increasing from -infinity to -5. Written with inequalities, like that. Second portion is increasing from -5, and it's going to go to the right forever to infinity. So you can write it like that, or you can write -5 less than x less than infinity. So which one? So -5 to infinity, check, and -infinity to -5. So those two, and we just got to check to make sure all the others they're not a portion. -infinity to infinity, well, there's this asymptote here that runs on the x. That portion is, that number -5 is not included. So this will not work because it's -infinity to infinity, and -5 isn't included because there's an asymptote. 2 to, or -infinity to 2. Let's check that. -infinity to 2. Well, it can't be because there's an asymptote. So that this number between -infinity and 2, that includes -5. And -5 is not part of our increasing interval. There's an asymptote there. 2 to infinity. Let's check that. from x value of 2 to the right to infinity. Does that increase? Slowly, but it does increase, so we have to circle that one. 0 to infinity. 0 is right here. To the right forever to infinity. Does that increase? Slowly, yes. Negative infinity to 0. Negative infinity to 0. Wait a second. No, can't, because there's an asymptote. And at that asymptote, there's not an increasing. And negative 5 to 2. Now you got to be careful. This means it's not included. So negative 5 is not included. That's the asymptote. And to 2. To 2 here. So that's this portion of the graph. Oh my goodness, there's stuff written everywhere. That from negative 5 to 2, negative 5 to 2 is here. And that is increasing, so that is part of it. That's a tricky one. That is part. All right.